So in our previous video, we have seen higher order differential equation in which we are finding complementary function. And in that we have seen the first type when the roots are real and distinct. Now we have only seen the explanation of complementary function, real and distinct roots. Let us take some examples to understand how these roots are obtained, and we will also study one concept called as a synthetic division, which we have seen in our lower standards. So it will be a quick revision. Observe the first equation. It is d3 or d cube x upon dt cube plus 23 d2 square d square x upon dt square and so on. An equation is written over here. Now over here, if you observe, x is your dependent variable and t is your independent variable. So it does not matter who is a dependent and who is an independent variable. What I'll do here is d by dt. D by dt I would call it as capital D. So my equation, this equation becomes 6 d cube x, because I've taken d upon dt as capital D. So it's 6 d cube x plus 23 d square x, because d by dt is taken as capital D. So that's d square. So it becomes d square and x. Then plus 29 dx plus 12x equal to 0. Obviously x is common. So let's take out x common from here. So I get 6 d cube plus 23 d square plus 29 d plus 12, and x is taken out common is equal to 0. So this entire function of d, this function of d is f of d, and we all know that auxiliary equation or the associated equation is given by f of d equal to 0. So I'll simply write 6d cube plus 23d square plus 29d plus 12 equal to 0. So that's my equation. Now my job is to find the factors. As I said, you can definitely make use of calculators to cross-check your answers, not to write the answers directly. You have to definitely get the roots by using mathematical calculations. So we will be using synthetic division. So now what the first rule of synthetic division is, whatever highest power is there, start descending from the highest power and write every single term. That means the first term, if you observe, it's d cube. So your next term has to be d square, next term has to be d, and the last term has to be constant. There is d cube, there is d square, then there is d also, and finally there is a constant. If any of the terms are missing, make sure to write that term accompanied by 0. For instance, if d square was not present, I would have written 0d square. If d was not present, I would have written 0d. But that does not apply to the constant. Do not write constant and 0 over there. If this constant was not present, the problem becomes very simple. From the three terms, you can definitely take out d common. D is taken out common, it becomes a second degree equation. As soon as it becomes a second degree equation, make use of the quadratic factors. So any of the two terms in between, either d square or d, if they are missing, make sure to write 0d square or 0d. In this particular question, that's not the case, because I have every single term present. So d cube was the highest power, then I found d square, I found d, and then the constant is present over there. Now the next thing that we should be doing in synthetic division is to write the coefficients d cube and write the coefficients along with its sign. So d cube has coefficient plus 6, so I write plus 6. D square has coefficient 23, so I write 23. Then d has coefficient 29, so I write 29. And finally I write 12. Now I have developed a very simple technique whenever such kind of a question comes. If I want to judge what roots this equation might have, I usually start putting the value 1, minus 1, 2, minus 2 in my equation. Whichever value gives me the value 0, whichever first value when I put in the equation gives me 0, that becomes my first root. So obviously when I put 1, it is definitely not going to come 0 in place of d. So I put d as 1. So it's 1 cube, 1 square and 1. So all the coefficients are with positive sign. So if I put plus 1 over here, nothing is going to get cancelled over there. So my answer is not 0 for value of d as 1. But now if I take d equal to minus 1, let's see what happens. If I put d equal to minus 1. So d cube, so it's minus 1 cube. Minus 1 cube is minus 1. So I get minus 6. D square, I am putting d as minus 1. So minus 1 square is plus 1. so I get plus 23. Then D I have taken as minus 1, so it's 29 into D, I get minus 29. And finally there is plus 12, it does not need the value of D, I write simply plus 12. So if I add these values, let's see what I get. Minus 6 and minus 29. So that's minus of 35 plus 23 and 12. That is also 35. Answer came 0. That means for sure you can say minus 1 is one of the roots. I said minus 1 is one of the roots. The power of the equation is 3. That means you will be very sure that D will definitely have 3 different values. It might be different, it might be same, but there should be 3 values of D. But how do I check which is the first value? I do not know. So the technique that I have told you, it is very simple. Write some numbers, 1, minus 1, 2, minus 2. You can go ahead also. If the answer is not coming 0, you can go ahead. You can write 3, you can write minus 3, 4, minus 4 and so on. You can keep on putting values until you get the answer as 0. So when I put minus 1, I've got the answer for the left hand side equal to 0. That means minus 1 is one of the roots. So I write, see I said minus 1 is one of the roots. So I'm going to write minus 1 here. 6 comes down as it is. I write 6 here. 6 into minus 1, it is minus 6. 23 and minus 6 will give me 17. 17 into minus 1, I get minus 17. Observe carefully how I started. 6 went down as it is. Minus 1 multiplies with 6, you get minus 6. 23 minus 6 will give us 17. Minus 1 into 17 gives me minus 17, so it is written here now. So 29 minus 17 I am going to do. If you observe 29 minus 17, you get 12. 9 minus 7, that's 2. 2 minus 1, that's 1, so 12. Minus 1 into 12, answer is minus 12. And the last value came 0. That means you can be very sure whenever the answer, the last answer comes 0, minus 1 is definitely the root of the given equation. Now, once I know that this is the root, now the next thing is to write the factor. So, the first factor, since minus 1 is the root, the first factor is D plus 1. That's your first factor. You want to write some other factors also. Now, if you observe these remainders, there is 6, there is 17, there is 12. See how do I write? The last term is your constant. 17 will come with D and 6 will come with D square. That means your equation here would look like 6D square plus 17D plus 12 equal to 0. Now if you observe, that's a quadratic equation. This is a quadratic equation. I can definitely factorize the quadratic equation. If you again observe, D square is accompanied with 6. If you remember from your lower standards, this 6 goes and multiplies with 12. So 6 into 12, you get 72. 12 into 6, that's 72. You need to find the factors of 72 in such a way that you should get 17 in the middle. So 72, obviously everybody remembers 9 into 8, that's 72. 9 into 8 is 72, and 9 plus 8 if you do, you get 17 also. That means the next thing that I should be doing is, I'll write it down like this. So that's D plus 1, then there is 6D square plus 17D, I'm going to split as 9D plus 8D. 9D plus 8D plus 12 equal to 0. So on simplification, let's see what do I get. So that's D plus 1. I write D plus 1 multiplies with. From here, definitely D is common. Then 3 is also common. It is 6D square plus 9D. That means 3D is common from here. So you take out 3D common from here. So 3D is taken out common. What is left? 2D plus 3. So I write 2D plus 3. Then again if you observe from the next two terms, so I have taken out 3D common from the first two terms. Look at the next two terms, 8D plus 12. Obviously you can say 4 is common. Again you are left with 4 is taken out common, so it was 8D plus 12. 8D plus 12, 4 is taken out common, you get 2D plus 3. So I write 2D plus 3. Close the bracket, equal to 0. So next step would be obviously D plus 1. Again 2D plus 3 is common, so write 2D plus 3. And finally 3D plus 4 3d plus 4 equal to 0. If you now go ahead, you can say d plus 1 becomes equal to 0, or 2d plus 3 becomes equal to 0, and 3d plus 4 also becomes equal to 0. So from here I get d as minus 1, d as minus 3 by 2 if you have a very close observation, and d as minus 4 by 3. So if you observe, I've got 3 different values of d. That means, as I said, this particular question falls into the first type. Roots are real. Minus 1, minus 3 by 2, minus 4 by 3. These are all real numbers. And they are different also. So roots are real and distinct. That means I can now write my complementary function as yc is equal to, the first root is minus 1, so I write c1 e raised to minus x. The value goes into the power of the exponential. Values will go into the power of the exponential. Then plus c2 e raised to minus of 3 by 2x and c3 e raised to minus of 4 by 3x. So that is how we get the complementary function of the first question. Now, the second question I'm going to give you for a practice, but definitely I'll discuss what the question is and how we are going to proceed. Observe carefully. There is dy by dx. So this time d by dx I'll take as capital D. So I'm going to write few steps about this question. D by dx is taken as capital D. So this becomes d raised to 4. It will be coming with y. Here also y. Here also y. Y and y. All the terms are containing y. So I'm going to d raised to 4 minus of 5d cube plus 5d square plus 5d minus of 6, and then y is taken out common. This is going to be equal to 0 for the auxiliary equation. Now that's the equation that you want to solve. It's a power 4 equation. If I want to solve a power 4 equation again by using the synthetic division method, remember the rules. The first rule says whatever the highest power is, start descending the power of d. Remember carefully, start descending the power of d. If any of the term is missing, you write it along with the coefficient 0. So there is d raised to 4. The next term should be d cube, it is present. Next term should be d square, that's also present. Next term should be d, that's also present, and the constant. Once you write all the coefficients and the terms of d, how do I decide the roots? I always take these first values, 1, minus 1, 2, minus 2. Take the value 1, put in place of d. See whether the answer is coming 0 or not. If 1 gives you the answer 0, be very sure 1 is one of the roots. If you observe, the power is 4. If the power is 4, that means definitely you get 4 roots. You have to get 4 roots, of which one of the root will become 1 if it satisfies the equation. Let's check whether d equal to 1 satisfies the equation or not. So if I put 1 here, so 1 raised to 4 becomes 1, 1 cube becomes 1, 1 square becomes 1, d again 1. So if you take the coefficients, what do you get? 1, minus 5, plus 5, again plus 5, and minus 6. Minus 5 plus 5 cancel. 1 plus 5 is 6 and minus 6. Everybody cancels. That means you can be very sure that 1 is one of the root. How do you proceed with the synthetic division? Write 1 here, write all the coefficients, whatever coefficients are there, and you proceed in the exact same way that I have done in the first case. So I want you to seriously give a try to the second question that is given out there, and then write the roots accordingly, and then finally once you write the roots, get the complementary function. So this is how we do a problem on the first type when the roots are real and distinct. Keep watching for the next types as well.